students, today we're going to talk about solving compound inequalities in your algebra class. So to start, I want to make sure you guys know that at the end of this lesson you should be able to solve multi-step and compound inequalities. So before we start, we need to go over two major types of inequalities. One is typically called an AND inequality, and the other is called an OR inequality. Now the difference between the two is simple but commonly mistaken. So AND inequalities are inequalities that enclose a certain domain. You might want to look at it as two rays or 2 points, two graphs that are going towards each other until they hit. OR inequalities are inequalities that have no intersection. Typically means that those two graphs are going to go away from each other. So if we look at the two examples below, this example is actually telling us that the lines are going in the opposite direction. So this is called an OR inequality because one's going to the left, one's going to the right, and they never intersect. This one right here is an AND inequality because they're going towards each other. And because they're going towards each other, it means they're going to enclose a certain domain. It means it has to be between -2 and 3. So let's try a couple examples. So for solving compound inequalities, we have two methods that we can work with. Method 1, which I tend to prefer, and I'll tell you why in a sec, is solving them simultaneously. Method 2 is solving them one at a time. Now I like using method 1 because it's faster and I feel like it's more efficient. It means we're not doing the same step 2 times in a row. So let's show you what I mean by that. We're always going to try to isolate the variable, in this case it's the s. Now, what we're going to do is we're going to start in the middle and figure out how to get it by itself. So, I want the s by itself, so we're going to get rid of the -1. And the way we do that is by adding 1 to both, usually it's both sides, but in this case there's 3 sides. So it's to all sides. So, we're going to add 1 to all sides. -9 plus 1 is -8 is less than -2s, which is less than or equal to -7 plus 1 is -6. Now, in order for us to isolate the s again, or to further isolate the s, we need to get rid of the -2. And the way we do that is by dividing by -2 to all sides. That gives us -8 divided by -2 is 4. And don't forget, because we divided by negative, we have to flip the inequality. So -2 divided by -2 is obviously just s. And again, because we divided by negative, this less than or equal to has to flip because we divided by negative, and that would give us 3. So the only other thing we'll have to do now is notice that the 3 is a smaller number and it's on the right. Typically we want the smaller numbers to be on the left, so that's the only thing we're going to do. We're going to write 3 is less than or equal to s, which is less than 4. Now notice, this is enclosing s between 4 and 3, which means this is an AND problem. To do it for method 2, to solve this problem using method 2, we're going to have to go through the same process. We're going to have to add 1 to both sides. -9 plus 1 is 8. -8 is less than -2s. Then we're going to divide by -2 to both sides, giving us 4 is greater than s. And we're going to have to do the same thing with the right side. So we're going to add 1 to both sides. We have -2s is less than or equal to -6. Then we're going to divide by -2 to both sides. S is greater than or equal to 3. Here's another benefit to doing it with the method 1 version. The inequality is already set up for us. Now, because we didn't do it here, we have to set it up again where they're together. So, smaller number on the left, so 3 less than or equal to s, which is less than 4. So, two methods for solving the same problem. Now, let's look at some pictures and this explanation, or not explanation, other example. It says, write an inequality for the given statement. It says all real numbers, n, that are at most -3 or at least 5. So notice because it says or, we're going to have two different statements. So we're going to start with n. That says n is at most -3. At most -3. That means that n has to be less than, less than or equal to -3. Notice because it says at most, it means it could be anything less than -3, but no more than -3, because it says at most, or equal to -3. Then it has a big or. Then it says n is at least 5. That means it has to be greater than or equal to 5. So notice that these two graphs would go in the opposite direction, which is why it's an or. The next two, we'll call this one problem 1, and this one will be called problem 2. We're going to have to write an inequality for each of these given the graph. So notice there's a huge gap in this problem, which typically means that it's going to be an or problem. So we have, starting on the left, x is less than -3, and it's less than, not less than or equal to, because this circle is open. So it's going to the left. Notice that the direction that our line is going also matches the inequality that we have. And the reason why this works is because x is on the left-hand side. So if we start with the x and just move on from there, usually the picture will help match it. So x is greater than 2. But it's not just greater than, it's greater than or equal to, because the circle is closed. So we have x is less than -3, or x is greater than or equal to 2. For our example 2, notice how we don't see arrows. They're going in the same direction. They're enclosed. So this is typically an AND problem. But in AND problems, we don't have to write AND because we're going to have the x being surrounded anyway. So we know it's an and the easiest way to do it is by starting with x in the middle, and we look on the right, and we see 3. So we know there's a 3 involved. Then we have to figure out, is x greater than 3 or less than 3, and then the or equal to portion. So x is less than or equal to 3, and it's or equal to because the circle is closed over here. And then we look on the left. It starts with -4, and x is greater than or equal to 4, -4. So that's how we graph this one. Now it's your turn. Solve these two problems given, and then I'd like for you to please post your answers to Edmodo. The first person to post will start. Everyone else will just reply to that thread. That's all for now, guys. I'll see you next time.